Hello there, this is Mr. Stewart, and I'm recording the audio after the fact. So this is kind of like a podcast. I'm just watching this with you right now. So what I'm doing is I'm circling the shifts that we have. Now, I made a little mistake here. I put the dot on 1, 0. It should be on 0, 1, and that's our reference point for exponentials. But that point gets moved down 2 and left 2. There's the left 2. There's the down 2. What that's also going to do is move the asymptote down. I made a mistake right there again. So that should be not at -1, y equals -1. That should be at y equals -2. And here comes the right one. So that's important because that establishes what the range is. The y values can't get any lower than -2. So here's just a quick sketch of the graph. I'm not really using any points other than a reference point. So my domain is everything. And my range is going to go from -2 to infinity. And we're not including -2 in that. So that's why it has a parenthesis, not a bracket. Okay, 2 and 3, we have some equations to solve. We want to isolate the base. So that's what I'm doing here. Getting rid of the 3, the -3, so I can get 11 by itself. Now I'm going to reach that exponent is I'm going to apply the log to both sides. And that log is going to make it so I can take the 10p, pull it out in front. Now divide by log 11 and also the 10 at the same time. This little delay is me looking this up on the calculator. I didn't really have time to edit this file, or the strength, or the will, or the desire. So here's a joke for you. What's orange and sounds like a parrot? I'll tell you after the next problem. So again, we're isolating the base of 16 by dividing by -6. We're going to apply the log to both sides. So I can take that p minus 7.1 out to the front. You notice I'm not dividing 31 by 6. I want the calculator to do that. And I want to leave all those decimals in there. Okay, so after this step, I'm going to have to add 7.1. That will isolate the p. So that's what the arrow means. It means I'm not recopying the side. It's not enough room. Now I'm calculating. Okay, the answer to the question, what's orange and sounds like a parrot? Answer, a carrot. That's the only joke I have today. But it reminds me of another joke. What's red and smells like blue paint? Red paint. Okay, so for the inverse, we're going to track the operations that happen to x. First it gets multiplied by -2, then you add 8 in that direction, and now we're going to reverse the steps and reverse the direction. So the opposite of add 8 and the opposite of multiply by -2. And there I go, subtracting 8 and dividing by -2. However, this might take place inside of multiple choice, right? So if I reverse x and 8, I can take the negative out of the bottom. All right, so isolating the root is always a very important thing to do. And now I'm squaring both sides because I want the square root to disappear. And now that's just a two-step equation to solve. It says, remember to check for extraneous solutions. That means solutions that came about through algebra, but doesn't satisfy the original function. But you'll find that n equals 1 does satisfy the original function. And this is me just checking that for sure. Usually you get an extraneous function when the root equals a negative number. And you end up squaring that negative number, it turns it positive. But a square root, for example, can never equal a negative number. This one works. Okay, the inverse again, so just look what's happening to n. You're doing an order of operations. First, you're going to take it to the 5th power. Then you're going to multiply by -1, that's the negative in front. And lastly, you're going to add 3. So we're just going to reverse those steps. And here it is, from subtract 3 to divide by -1 and then a 5th root. And again, I could take that negative out of the bottom and I could use it to reverse what it says on top. Number 7 is a translation problem. 1, 2, 3. Number 1, the base is the base. The base of the log is the base of the exponential. 2, the log is equal to the exponent, so that's why 2 goes on 20, and 400 only had one place to go. I solved that one really fast. Okay, now I'm taking negative exponents and putting them on the other side of the fraction. And that entire x to the 4th, y to the 3rd comes to the bottom. And now you've got a division of the x's, so you're going to do subtraction, and a multiplication of the y's, so you're going to do addition. They turn out to be the same thing. All right, we're expanding. First, we're going to bring that exponent out to the front. Okay, now we're going to split the multiplication into addition. And I forgot to do the other exponent of 5. So I'm going to bring that out to the front. And the last thing is to distribute that first 5. Multiply it in. There we go. Okay, on this one, I'm first going to reduce a few things away. Flip the negatives to where they're going to be positive. And then just combine together, v to the fourth and v to the third. That one went pretty quick. On number 11, we're going to solve that one without logs. So we need to express both sides as bases, the same base. Now you could do 16. Well, no, you couldn't do 16 because 16 squared is big. It's like 256. So I guess you have to go back to 4. You will have to distribute now. So that's why I have 6m instead of 3m plus 1. I have 6m plus 2. I distributed the 2. On the right side, I distributed the 3. And now I'm just solving. And this is just, basic equation solving stuff. I am checking my answers as I go through, so sometimes there's a little delay. We're isolating the base again. And then we're going to use a log on both sides so that we're able to bring that exponent to the front. Now that exponent's in the front. And we want to isolate the r, so we're dividing by log of 18. I could also have divided by -6 on that same step. I don't know why I didn't. So when you put this in a calculator, just keep typing divide. The log divided by the log divided by -6. And I'm punching it out on my calculator now. Boop, 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 boop. I don't think I rounded to the correct number of places here. This says 10,000. That would be, let's see, tens, hundreds, thousands. That would be 4 decimal places. I only did 3. Sorry about that. I realized about halfway through this I wasn't rounding the decimals like it said to round them. Okay, numbers with the numbers, letters with the letters. And I'm bringing the negative exponents up. I was almost going to bring that y to the 4th up, but I decided not to. And now we're just going to cancel the y's and combine the x's. On 14, don't forget to square the 2 as well. And then I was combine the x's, and then I realized I needed to square it. So there's our answer. I give you a lot of these ones, like number 15. Should be able to do these really well. It's almost the same as the last one like this. We've got to put the log on both sides so we can bring the exponent down to the level of the regular numbers. You need parentheses there because you don't want the log to look like it's just getting multiplied by the 8.2. It's actually getting multiplied by both because both were in the exponent. Okay, there's a move to isolate. And finally, we're going to add that 8.2 to solve for x. Put that in the calculator. And what do we get? Yeah, I'm waiting on just along with you, but you can fast forward. Okay, great. I don't think number 16 said to graph it. It said find the domain and range. Why do they provide a graph then? Well, that's just to help you. So if you can visualize what the graph looks like, then you can figure out the domain and range. Or at least you stand a better chance to. So I'm going through my shifts of the reference point, and that's going to help me see where the asymptote comes in, because it also gets shifted. And then here's where approximately the graph would go through. So again, domain is going to be everything. For all exponentials, the domain is everything. And the range is going to start just above the asymptote. So the asymptote is now sitting at 2. Sitting at 2. So anything above 2. Okay, 17, we've done one of these before. Base is base, log equals the exponent. 16 goes over there. And for 18, division is going to change to a subtraction. And then we're going to bring those exponents out to the front. And there we go. Number 19, both 36 and 216 are powers of 6. 6 to the third is 216. How do I know? Well, just years and years of doing this. I will have to again distribute the 2 to the 3 minus 2r. So remember, our argument is that if the bases are the same, then the exponents must be the same. So now on this next step, we're not really applying a log, we're just saying exponent equals exponent. And should that be a decimal or a fraction? Well, you know, you're preparing for a multiple choice test. On the last one, number 20, we're going to square to undo the square root. And then it's just a simple two-step equation from there. All right, I think that's it. Our time is coming to a close. Bye-bye.